The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today, eventually we're going to go on and cover section 8.3. But first, I had a question that came to me by email, so we'll take a look at that. This is problem number 7 from section 8.2, part 2. So 8.2, part 2, number 7. It says, write an equation for a linear function whose graph has the given characteristics. It passes through the points -2, 2 and 2, -12. So let's go back to the whiteboard screen and take a look. So I need to come up with the slope and the y-intercept. Then I can put them into slope-intercept form and create the function. I don't have either the slope or the y-intercept, but I do have two ordered pairs. So I'll call this point 1 and point 2. So this will be x sub 1, y sub 1, x sub 2, y sub 2. Using the slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we'll put the numbers in there. Y sub 2 is -12. Y sub 1 is 2, x sub 2 is 2, and x sub 1 is -2. So we get -12 minus 2, which is -14, over 2 minus -2. Subtracting a negative is like adding a positive, so we get 4. This reduces down to -7/2. So the slope is -7/2. Using the slope-intercept form, y equals mx plus b. We're going to take the slope and put it in the place of m. So we get y equals -7/2 x plus b. Now I need to find the y-intercept. I can use either one of the original 2 points, picking the x value and the y value from just one of those points. I'll go ahead and use point number 1. So x becomes -2 and y becomes +2. So I get 2 equals -7/2 times -2 plus b, which is 2 equals -7 times -2 is 14 over 2 is 7 plus b. Subtract 7 from both sides and b is -5. So I know the slope and the y-intercept. So y equals -7/2 x minus 5. Finally, as a function, f of x equals -7/2 x minus 5. And there you have it. Any questions about that particular problem? All right. Do you have any questions, those of you that are here, that you'd like to look at from yesterday's assignment before we go on? Okay, then we will continue on. So give me just a minute here, and we're going to switch screens. Okay. Okay, so what we have is a problem and a graph. The graph is this straight line. It's labeled here f, so this is the graph of the function f. Okay, can everybody see that all right? Am I sharing the right screen there? Let's make sure. Okay, now this is actually a question. It says f of -2. That's the same question as if we were to say Complete the ordered pair, -2, comma, what? Okay, so we need to find the corresponding y value when x is -2. So we're going to go to the graph and find the point that has an x value of -2. Well, here's -2 for the x value. So right there would be the point, right there specifically, that has an x value of -2. The corresponding y value is -4. So f of -2 equals -4. Any questions about what I just did there? All right, we're going to do that again. Now we want f of 0. So where on the graph is there a point with an x value of 0? That would be right here. And the corresponding y value is also 0. So f of 0 equals 0. Any question on that? So those first two questions were basically given x, find y. In this case, it was this. In this case, it was that. The next two questions are just the opposite. It says the value of x for which f of x is 4. So now they're telling us the y value. Remember, f of x is a function notation name for y. So we want to find the point on the graph that has a y value of 4. Well, y equals 4 is up here, right there. The corresponding x value is 2. So we would say, let's see, we'd say x equals 2. Okay. Next question. The value of x for which f of x is -2. Well, f of x or y equals -2 is right here. So we're looking at that point. The corresponding x value is -1. So x equals -1. Again, corresponding to the situation where they said y is -2. What's x? It's -1. So, any questions about this example? Anything you're not sure about there? So the first two, they were giving us x, saying find y by finding points on the graph. The second two are giving us y, find x. Okay. Same exact idea, but now we're dealing with the function that is called s. So s of -3, we're looking for a y value that's on the graph when x is -3. Well, when x is -3, y is 2. So we'd get that answer. Then it says s of 3. Well, let's see. X is 3 when y is 4. Any questions about those two problems? Okay. Now, the values. Notice it says values, not values, so there's going to be more than one. The values of x for which s of x or y equals 0. Well, where does y equal 0? The x-intercept. So that would be this one, and this one, and this one. So x is what? -1, 1, and 5. X equals -1, 1, 5. So you'd have those three x values all have the same y value as 0. Then the values of x for which s of x is 3. S of x equals 3 is right here. So we'd have what? 2 and 4. So x equals 2 and x equals 4. Are we okay with that? I'll take that to mean yes. Next example. Same thing again, but a different graph. Oh, this is the graph of G. So G of -2. When X is -2, Y is +2. G of 0. When X is 0, Y is also +2. The value of X for which G of X equals 3. The value of X for which Y equals 3, X would be -1. The values of X for which G of X is -1, that would be what? -3 and +1. X equals -3 and +1. Any question on these examples? Okay. This says find the domain and range of F. So the domain is all the X value inputs that yield real Y values, and the range is those resulting Y values. Well, if we look at our graph, we see that we have, a linear function. These arrows imply that the graph continues on in both directions. Going to the right as it goes up, it's also going over. To the left as it goes down, it's also going over. So the domain would be all the X values, which would be all real numbers. The range, likewise, would be all Y values, so it would be all real numbers. Any questions about that example? Okay. Find the domain and range of F. And again, we're going to use interval notation. Well, as this goes up, it's going over, and as this goes up, it's going over, and so it's going from negative to positive infinity in terms of X. But the Y values, the lowest Y value is 3. So we're going to start at 3 and then go on up to positive infinity. But there are no Y values less than 3. Recall that the bracket means you include that point. Parentheses means that you exclude that point. All right, well, I'll just continue on unless you interrupt me with a question. Find the domain and range of F. Okay. The domain, well, the X values start where? At 0, and then go on forever to the right. So the domain would start at 0 and go on to positive infinity. The domain would. The range, we take domain and range from smallest to largest. So since this thing is going down as it's going over, it's going to go all the way down to negative infinity, but it's going to go up only as far as 0. So the range would look like that. The domain is 0 or greater. The range is negative infinity up to, but including 0. All righty. Now we're going to sort of combine those two different kinds of questions. Find F of 1. Oh, but look here, the scale has changed, so be careful of that. On the x-axis, 1 square is 1 unit. When I don't label it like I did in the previous ones, you can always assume 1 square is 1 unit. But if it's anything different from that, you better label it. So on the x-axis, the scale is 1 unit or 1 square is 1 unit. On the y-axis, 1 square is 5 units, 5, 10, 15, 20, 25, etc. Okay, so F of 1, when X is 1, Y is 15. f of -3, when x is -3, y is 5. The values of x for which f of x is 0. So where is y equal to 0? Here, and here, and here. Basically the x-intercepts, which would be, let's see, x is -4, -2, and 0. Okay. Any questions there? Domain and range. Let's see here. Domain and range. Well, as this is going up, it's also going over. Same thing as this is going down, it's going over. So your domain and range for this example are going to be all real numbers. Okay, find g of 1 when x is 1, y is 2. Okay. G of -4 when x is -4, y is -5. The values of x for which g of x is 4. So when is y equal to 4? There, when x is -2, and there, when x is +2. So x equals -2 and +2. The domain, as this is going down, it's going over. As this is going down, it's going over. So it's going to go on the x-axis from -infinity to +infinity. However, the range, this goes down, but the highest range value is 4. So it would go from -infinity up to and including 4. All right. 72. New set of directions. This says, determine whether each graph is the graph of a function. If it is not, find two ordered pairs where more than one value of y corresponds to a single value of x. Okay, we're going to introduce something that's called the vertical line test. Basically, I'm going to take the graph and I'm going to go across and draw a series of vertical lines. Any one of those vertical lines that cuts through the graph more than once shows that it's not a function. Because, for instance, let's take a look at, let's draw that line a different color. Let's take a look at this line right here. Okay. That represents what? An x value of 3. But when x is 3, y takes on 2 different values, doesn't it? So one input has more than one output. Okay. Now, it's kind of hard to tell the coordinates of those two, but how about let's take a look at these 2 points. Okay. So let's see. X is, well, in fact, let's get rid of all this mess here. We'll go back to, and let's just take a look at this line right here. Okay. When x is 1, y is 2, and when x is 1, y is -2. So there's a set of 2 ordered pairs that show that this graph is not the graph of a function, because for one input, 1, y has 2 outputs. Y is 2 or y is -2. Okay? So this is not a function, not a function. It fails the vertical line test. Okay, let's take a look at another example. How about this one? That's kind of a strange looking graph, isn't it? Is this a function or not? Let me remind you, an open circle like this means that that point is not included on this piece of the graph. This open circle, it's not included, same thing here. So what do you think? Does this pass the vertical line test? Anybody?
Seems like it does.
It does, that's correct. So this is a function. Yes, it is a function. Now, if I were to go in and fill in any, let's say if I were to fill in, let's mess with this, and let's say that we were to fill in this dot right there. It would no longer be a function because it would fail the vertical line test. When x is -2, y would take on two values. Y would be 1 or y would be -2. So if that was filled in, it wouldn't be a function, okay? But as it is, it's a function. Good. How about this one? Is this a function? A circle? Well, my feeble attempt at a circle. I drew this thing about 8 times, and this was the best I could do. Oh, well.
Even if we're just looking at it to evaluate that, when we say.
Okay, so this is not a function. So let's see, how about we could use these 2 points to show that it's not a function when x is 3, y is -2, and when x is 3, y is -6, okay? Which would basically come from that vertical line, okay? So, not a function. Alrighty, so basically this is getting to understand function notation a little better and extracting information off a graph of functions or non-functions. Okay, that's all I've got for you today. I'll be back at 1:15. So if you have any questions, be sure to come back then. Otherwise, have a great rest of the day, and I'm going to stop the recording.